Exercise 13 of section 2.5 asks us to determine whether the two lines are parallel, perpendicular, coinciding, or only intersecting. So one of the things that I want to mention again is the fact that we have three forms of the lines we've looked at. We've looked at the standard form, we've looked at the point slope form, and we've looked at the slope intercept form. Of those three forms of the line equation, only the slope intercept form is unique. There's one and only one slope intercept form of a line. So, in order to determine if the lines are parallel, perpendicular, coinciding, or only intersecting, we need to get this in slope-intercept form. So we want to solve for y. So we'll add a 9x to both sides of this equation. So we wind up with minus 3y equals 9x minus 6. And we divide every term by negative 3. And that gives us y equals negative 3x plus 2. Now let's take the second equation, 4x minus 12y equals 6, and let's solve this one for y. So we'll need to subtract 4x from both sides. So we get negative 12y equals negative 4x plus 6. And let's divide each term by negative 12 in order to isolate y. When we do that, we obtain y equals 1/3 x. Negative 4 divided by negative 12 is positive 1 over 3. I can divide top and bottom of this fraction by negative 4. Minus 1/2. So I see that, let's call this line L1, and let's call this line L2. So I see that M1 is negative 3, M2 is positive 1/3. If I multiply these two together, I do get negative 1. And obviously, if I recognize that they are negative reciprocals of each other, if you invert 3, you get 1/3. If you change the sign of negative 3, you get 3. If you invert 3, you get 1/3. And so that's the relationship that has to exist. All right, so these are perpendicular. So that would be what I would select. The product of their slopes is negative 1. In the next problem, we want to determine the same thing. Are the lines parallel, perpendicular, coinciding, or only intersecting? We already have the first line in slope-intercept form, and we want to obtain that form for the second line. And we'll do that by adding a negative 8x to both sides of the equation. So when I do that, I obtain negative 2y equals negative 8x plus 7. And then I divide every term by a negative 2. So I wind up with y equals negative 8 divided by negative 2 is positive 4. Y equals 4x minus 7 over 2. And I notice that my other line is y equals 4x minus 8. So if I call this L1, this one is line 2, then obviously M1 equals M2. Both slopes are 4. So, and the y-intercepts are different. So these are parallel lines. Parallel lines have the same slope but different intercepts. All right, here we have the same question. We want to determine if these lines are parallel, perpendicular, coinciding, or only intersecting. So we see the first equation is y equal negative 1. The second equation, in order for me to isolate y, I need to divide both sides of this by 3. So 3y equals 12 needs both sides to be divided by 3, and I get y equals to 4. So notice these are two horizontal lines. Remember, the equation of a horizontal line only tells you about y. All the points on a horizontal line have the same y coordinate. And two horizontal lines are, of course, parallel. Okay, here we have the same question, but we have the line x equal negative 5. So that is a vertical line. Every point on a vertical line has the same x coordinate. Here I have y equal negative 5, which is a horizontal line. Every point on a horizontal line has the same y coordinate. And then I need to realize that every vertical line is perpendicular to every horizontal line. So these lines are perpendicular. All right, for exercise 17, we have the same question. We want to determine whether these two lines are parallel, perpendicular, coinciding, or only intersecting. And so we will put both lines in the slope-intercept form. So the first line, we do that. Our first step is to subtract 7x from both sides. We can look at that as adding a negative 7x. So we have negative 6y equals negative 7x plus 3. And I am going to divide every term by negative 6 to isolate y. So that gives me the slope-intercept equation. Y, negative 7 divided by negative 6 is positive 7 over 6 times x. Positive 3 over negative 6 is negative 1/2. All right, so this is my first line. Now let's look at the second line. All right, I start with 8x minus 9y equal -1. I'm going to subtract 8x from both sides. Or I can look at it as adding a -8x. And I get -9y equals -8x plus 1. And then I divide every term by -9 so that I can isolate the y on one side of the equation. So my slope-intercept form of this line equation is y equal -8 divided by -9 is positive 8 over 9. Y equal 8 over 9x minus 1/9. So notice if I multiply 7/6 times 8/9, so m1 times m2 will not equal to -1. M1 doesn't equal M2. And if these don't have the same slope, there's no way they're going to be coinciding. Coinciding lines have the same slope and the same y-intercept. So essentially they're two different equations of the same line. So these are only intersecting. If lines aren't perpendicular and they're not parallel and they're not coinciding, then they're merely going to be only intersecting. As long as you extend them far enough, the two lines will intersect.